Hi guys, so sorry to miss you this week. We just had a whirlwind trip down to Wisconsin and back, but I was very sorry to miss you and sorry to miss the opportunity to say goodbye to you guys. It's been a really great year, and it's been wonderful to get to know you and to work with you through a lot of the major issues in human geography. So I think you all have done really well, and I've been impressed by your skills in analysis and your willingness to participate in class and participate in looking at some of these big issues, talking through them, debating them. And I wanted to kind of wrap up the year by looking at some of the major issues we've looked at lately. As we've seen over the last few weeks, one way to kind of break down some of the future of the world and the future of human geography, the impact that humans will have on the environment and that the environment will have on humans, is to break it down in terms of elements: air, earth, fire, and water. And so we've done that over the past few weeks, and I wanted to give us one more resource looking at each of those elements. Air, of course, being air pollution, water being water quality and usage, earth being agriculture, and fire being energy use. So I've sent you guys links to 4 resources that have to do with each of those, and what I want to do in this video is to look at each of those and so for the videos, I'll just ask you to pause the video. I'll ask you to pause this video. Ask you then to go to the video or the resource and either watch it for the first time if you haven't watched it, or just give it a quick second look, and then come back to this video and participate a little bit in the discussion. So let's first take a look at the article about air pollution, which is under the link that I put after the word air in the email I sent you last week. Okay, so as we look at this article, this is an article by Earthscene, which is a semi-reputable source. But what I liked about this article is that it broke down this report done by the journal Atmospheric Chemistry and Physics, which is also a reputable journal. And what it did is taking a look at pollution going forward, right? So, one of the things that we, have looked at is what is happening to air quality. Why does it get worse and better? What can we do about smog? What can we do about greenhouse gases? And what are the best ways to avoid and reduce air pollution in the future? So this article does a good job of looking at what this journal and what this group of scientists has predicted air quality will look like going forward. You can see, in this map that they give at the top of the article, that we do have pollution in local areas, but whatever pollution goes into the air is shared around the world. It's the nature of gases to expand, and they expand ultimately to fill the entire atmosphere at very, very, very diluted levels, right? So so the molecules in gas tend to spread out, essentially infinitely until they populate all over the atmosphere. So pollution in China does reach us in some ways, and our pollution does reach China in some ways. So it's important when we think about pollution that it's not just about the people who are immediately affected, but also the impact on the air quality globally as well. So this article, I would like you to go ahead and read the full article, but I'll point out a couple of highlights. One thing that they point out is that the World Health Organization, an extremely reputable organization, that is a UN, a United Nations organization, and they do a lot of great statistical data collection. They found that outdoor air pollution causes 1.3 million deaths per year. That is obviously something that we can avoid with the right solutions. So we have one other highlight here is that we have a high level of carbon monoxide, as shown here, where we're getting up to 250 parts per million. That means, per, let's say you have 1 million liters or 1 million, quarts of air. Of that 1,250,000 of them are pure carbon monoxide, right? But of course, that carbon monoxide is diluted across that, billion parts. Carbon monoxide, of course, is a gas